Hey, what's up, everyone? Today we are going over our Unit 2 Test 1 review. So we're going to be going over problems that are similar to the ones that you'll see on your test. And if you follow along, take some notes, you should do wonderful on that test. So let's get started. Our first problem says, what pair of rigid transformations will map triangle ABC onto triangle A prime, B prime, C prime? So a couple things we want to notice and really point out here. It says, what pair? So that's more than one transformation. So first of all, we need to remember our transformations that we went over. First, we had a translation, right? That was our first one. Then we had flexion and rotations, right? So we have these as our options, but we want to be specific with them, like a translation where, a reflection how, a rotation around what, right? So first thing we could do is we could see, hey, how does A, B, C get to A prime, B prime, C prime? That's the first thing we want to do. And what we notice is they have the same orientation, aka they're looking the same directions. When that happens, right? That means we only have one option here, and we're using a translation. So we could just take one of our points. So I'm going to choose B, and we're going to say, how do I get from B to B prime? I'm going down 1, 2, 3, 4, 5, and left 1. So my first thing, put in number 1, I'm going to say down. Ooh, let me actually write the word translation. Right, so translation down. How many did I say? I think I said 5. Yep, down 5 and left 1. Awesome. So that's our first transformation. And our second one, now look, these are facing opposite ways. So what's happening here? This is a reflection. Where is it a reflection of? Well, if we notice from C prime to C double prime, they're 4 units away from each other. 1, 2, 3, 4. The middle point of that is right here. This is my y-axis, which means that my y-axis, since it's the middle between those 2 points, is our line of reflection. So we are reflecting over my y-axis. Awesome. And those are our 2 transformations here. Those are the rigid transformations that will get A, B, C onto A double prime, B double prime, C double prime. Awesome. Next up, it says the figure shows rectangle PQRS in the first quadrant of the coordinate plane. Rectangle PQRS is reflected across the x-axis. But what I'm going to do is I'm kind of just sketch that out. If we reflect this, it's going to look something. Right? Ooh, that's not a good rectangle, but you guys know what I'm talking about. And that's going to be Q, R. Actually, sorry. Reverse. Messed up with that. This should be Q, R, E, S. Because P is the closest to x-axis here. So then P prime be closest to x-axis there. So that's my shape. Which 2 further transformations will carry rectangle P prime, Q prime, R prime, S prime back onto PQRS. So first one says reflection across the y-axis followed by reflection across the x-axis. If that happens, if we flip this over to my y-axis, it's going to be located here. And then we flip it up, it's up here. Is that back on itself? No. So A is not my answer. B says a reflection across the y-axis followed by a reflection across the line with the equation y equals negative x. The reflection across the y-axis will bring me here. My line y equals x is a diagonal line going like that, downward across our grid, and that would flip us back up here. Now, would that give us what we want? Not necessarily. Because as we can see also, there's a checkpoint here. This means this is the right answer. A reflection across our y-axis followed by a 180-degree rotation. So if we reflect this across our y-axis, 180 degrees brings us halfway around. Think of it like a semicircle. It's halfway. So this is our answer. Whoa, that line is sloppy. Boom, boom, boom. There we go. There's our answer. Next up, complete the truth table for the conditional statement. If an animal is a turtle, then the animal is a reptile. So the best thing about these truth statements is they all follow the same pattern. So our pattern is, if P is true and Q is true, then our whole statement, true. If P is true and Q is false, our whole statement's false. And then for our next true, P is false, Q is true, that's true. And then P is false, Q is false, that's true. Let me run through kind of like an example. Well, if an animal is a turtle, then yeah, it's going to be a reptile. But if an animal is a turtle, then it's not a reptile, which is what the second line's saying. That's false. That doesn't make sense. If it's a turtle, it can't not be a reptile. Next, if an animal is not a turtle, then it's a reptile. That's true. That works. And then last, if an animal is not a turtle, then it is not a reptile. That also works, right? Because we have animals that aren't turtles that are reptiles and animals that are turtles that are not reptiles. This is our pattern. And if you know this grid right here, this works for any truth table, for any statement, any conditional statement, this works. Next up, it says if angle ABC forms a linear pair with angle CBD, use the linear pair postulate to determine the value of x. The linear pair postulate says that if we take two angles and they create a straight line, like we have here, that means they equal 180. So what we could say is, if I add my angle ABC plus CBD, that's going to equal 180. So angle ABC plus angle CBD, right, equals 180. So then now we could substitute in information. ABC equals 2x plus CBD, which is 13x minus 15. That equals 180. Awesome. Now we just have to solve this. And in order to solve this, what do? First thing we want to do is combine like terms. Now I'm going to bring my problem kind of up over here. So 2x plus 13x will give me 15x minus 15. Now we have to solve and get that x by itself. First thing we do is we add 15 to both sides, work from the outside in towards my x. So we have 15x equals 180 plus 15 is going to give me 195. Now we just need to divide. Get out your trusty dusty calculator if you need to. We say 195. We're dividing both sides by 15 here. 15 divided by 15. And we get x is equal to 13. Don't mind my Activate Windows here. This, if you could see that on the screen, I don't pay for my Windows. It's the free version. So x equals 13. There we go. So you just set up your equation using the linear pair postulate, and then you solve. You substitute in your information and solve for x. So next up, now instead of having a linear pair, it's saying that our bigger angle here, RQT, is equal to 125. So if we add these two angles together, they need to equal 125. So we could say 3x minus 10 plus, because we're adding the two angles together, 4x plus 9 equals 125. Once again, combine like terms. We're doing different underlines for different terms. 3x plus 4x gives me 7x. Negative 10 plus 9 is going to leave me with a negative 1. And we didn't touch anything on the right side of my equal sign, right? Now we add 1 to both sides, doing our order of operations in reverse. We get 7x is 126. Once again, got to break out that trusty dusty calculator. So we do 126 divided by 7. So we're dividing both sides by 7. Whenever you have a number next to your variable, whether it's x, y, z, right? If you have a number next to it and you want to get rid of it, you divide by that number. They cancel out and we're left with x equals 18. Beautiful. So there we go. But is this what our question's asking? No, it's asking what is the measure of RQS and the measure of SQT. Now we need to plug this in. So we get 3 times 18 minus 10 for 1. and then 4, be a parenthesis, times 18 plus 9, right? For the other. And all you have to do is plug these into a calculator. So for 3 times 18 minus 10, that gives me 44 degrees. And then for my other one, 4 times 18 plus 9, that gives me 81. And you know if you did this right, because what is 44 plus 81? Yep, you guessed it. That gives me 125, which is exactly what we wanted. We did our problem correct here. Awesome. Next up, it says suppose segment AD is congruent to segment CB, right? Ooh, this is going to be a congruency thing. So we want to say, let's mark this off. AD is congruent to CB right here. Awesome. And then ADB, which is ADB right here, is congruent to CBD right here. Are there congruent triangles? Whoa, sorry. And yes, the answer is yes. Why? Because they share this side. We have a triangle right here, and we have a triangle right here. And those two triangles share side DB, right? DB is congruent to DB, and we know this because what we call our reflexive property. Basically, hey, something's congruent to itself. So we can say, due to side, angle, side, or looking at it from this triangle, side, angle, side, so side, angle, side, that triangle ADB is congruent triangle CBD. Why? By the side, angle, side congruency theorem. Beautiful. So next up, it says Julia believes that triangle ABC was rotated 90 degrees clockwise to create triangle PQR. Is she correct? If not, use the information to the left to rotate the triangle 90 degrees clockwise and drawing it in the coordinates listed. So, is it 90 degrees clockwise? The answer is no, right? 90 degrees wouldn't bring us to this quadrant here, right? So if we do rotate it 90 degrees clockwise, now that is 270 counterclockwise rule. What we do is we're using this rule right here. We're taking our coordinates and we're switching them. We have to write our coordinates first. So the coordinates for A is -5, 2. B is -3, 1. And C is -1, 5. So our new coordinates, by applying this rule, is we swap it, and whatever was up front comes to the back, right, and changes sign. So A prime will be 2, 5. B prime is 1, 3. And C prime is now 5, 1. We just graph these, 2 up 5. We get A prime. B is at 1, 3. That is B prime. And C is at 5, 1. And C prime. Connect those. Sorry that my drawing's not perfect. And there we go. That is our rotated triangle. So this is rotating like that. Rotating 90 degrees clockwise. All right. So for our next problem, we have a lot going on here. But it says, in the figure below, triangle PQR is a reflection of triangle TSR. So we have to think about reflections and what happens to when we reflect something. It's just a flip, right? Nothing really changes about the shape besides where it's facing and where it's actually located, right? But it's just flipping it over. So it says 2 students describe the given triangles as shown. Because reflection preserves side lengths, which is true, the sides will stay exactly the same, right? It says QR is congruent to SR, PQ is congruent to TS, and PR is congruent to TR. That's all true. All the side lengths are congruent in one to the other. So the student says triangle PQR is congruent to triangle TSR by side, side, side. That's true. Says student 2, because reflections preserve both side lengths and angle measurements, Also true, right? The sides aren't going to change, the angles aren't going to change, nothing about the measurements of the triangles change. It says angle RPQ is congruent to angle RST, QR is congruent to SR, and PQ is congruent to TS. So triangle PQR is congruent to triangle TSR by side angle side. For this one, the only thing we have to make sure is that they're in the right order, right? It is a side, there is an angle, and there is another side, right? But let's make sure that they're in the proper order. So let's mark things off. RQP is this angle right here. And then RST is this angle right there. And then QR is congruent to SR. QR, SR. And then PQ and TS. PQ, TS. And yes, that does give me side angle side. So we have side angle side in my left triangle and side angle side in my right triangle. That gives me the side angle side that we're looking for, which means that student 2 is true also. So they're both true. So we're going to choose C. Both students are correct, and both ways will prove that these triangles are congruent. Awesome. Next problem. It says, suppose V is the midpoint of UW. So we're going to need to show things here, right? So let's mark that off right away. If V is the midpoint, that means UV and WV are congruent. Those two segments right there are going to be congruent. And it also says TV is congruent to XV. So TV right here and XV is right there. What additional information would you need to conclude that triangle TUV is congruent to triangle XWV? They want us to use side angle side. We have two pairs of sides here, so we need to find the angle that's in between them. The angles that are in between them, I'm going to mark off right here. Boom and boom. So all we need to do is figure out the names of those angles. And fun fact, those angles are congruent because they're vertical angles, and we know all vertical angles are congruent. So now we just have to figure out the names. So this one could be named TVU, and this one would be XVW. So these are not angles. We're not choosing it. Not angles. We just have to decide between C and D, right? So UTV. Did I say UTV? UTV. No, that would be this angle all the way up here. So this is not our answer. And D is the answer here. Just knowing to name those angles. All right, and our last problem for our review says, John determines that sides MO and JL are congruent. I want to mark those down, right? Whenever we told something's congruent, I'm going to mark it up in my picture. So JL right here and MO are congruent, which we could actually determine just by looking at the graph because you could count, right? 1, 2, 3, 4. 1, 2, 3, 4. They're both 4 units long. Yeah, they are congruent. He also measures angles O and J and determines that they are congruent. Angles O and J. So J is down here and O is right here. So they're congruent. And it says, he concludes that the triangles are congruent by side angle side. Is John correct? If he is correct, which congruency theorem should John use? Explain your reasoning and show your work, including the measures of the line segments. So the problem here is he said side angle side. We don't necessarily know that yet, but we could figure that out. We are missing ON and JK, right? We would have to use our distance formula, or we could use the idea of slope, right? So kind of using the idea of slope here. So what we could say is if we want to get from O to N, we're going up 1, 2, 3, right? We're going up 3, and we're going right 1, 2, 3, 4, 5. Up 3, right 5, right? And that's ON. If this JK is the same type of movement, right? So either right or left, or now we want to go right or left 3, and then up or down 5, right? So 1, 2, 3, 1, 2, 3, 4, 5, right? So 3 and 5. Yes, these are congruent, right? So we could show that these are congruent because they have basically the same slopes but going in different orders, right? So This would actually be, sorry, -3. But these are congruent, so they do work. So yes, triangle. We could say that triangle, how do I name that top one? NOM is congruent to triangle. If I name that one NOM, this one would have to be KJL. Following corresponding parts, and that's because of the side angle side congruency theorem. And there we go. We are done with our review. These are all the problems that you might see or similar problems like this on your quiz. If you have questions, comments, or concerns, please don't be afraid to reach out. Ask for help if you need it. If you need anything clarified or are confused about any of it, let me know. Good luck, have fun, and I'll see you all next time. Peace!